In 1915, Ray Carter, a pattern maker from Syracuse, New York, borrowed his barber's electric clippers. Except it wasn't clippers like these. These came a few years later. It looked more like this flexible shaft tool with clippers instead of a chuck. Carter removed the clippers, the flexible shaft, and mounted a cutter directly on the motor and then put the motor on a base. He created what he called a hand shaper and what we remember as the first router. Carter patented his idea in 1922 and started a cascade of portable power tools. This cascade turned into an avalanche in 1961 when Black & Decker, who was working with NASA to create battery-powered tools for astronauts, introduced the first cordless drill. Today's woodworking shop is home to dozens of portable power tools. My shop is a perfect example. These are the portable tools that Travis and I use on a regular basis. Mostly. And this is after the garage sale. There are probably dozens of more hiding in the corners that we have completely forgotten about. This mess creates a unique problem: how to store and organize these tools so you can easily find and retrieve them. Fortunately, I have a unique solution. These are pigeonhole shelves. They were originally built to sort mail, but my grandfather salvaged it and used it to sort small tools. I'm still using it for the same thing. It dawned on me a little while ago that if I made these shelves a little bigger, well, you see where I'm going with this, because this is a pigeonhole cabinet. At least that's what I'm calling it. All those portable power tools that you saw stacked on my workbench a few moments ago, they're now neatly stored, well, sort of neatly stored, in the cabinet. But unlike my grandfather's pigeonholes, the shelves in this cabinet slide in and out, so you can easily retrieve and replace stuff. Furthermore, the spacing between the shelves is adjustable in 2-inch or 50mm increments. And the width of the shelves changes across the face of the cabinet. You can choose a shelf as wide as 12 inches, 305mm, or as narrow as 6 inches, 152mm, depending on the size of the tool. And this cabinet is surprisingly economical to build. You can make it with just 2.5 sheets of plywood, and for me, one of those sheets was scrap. All these shelves, they were little pieces of plywood that I had lying around and my OCD wouldn't let me throw away. And as you can see, it's absurdly easy to build. It's just a big box with dividers, and this makes it easy to modify to your own needs. If you need more or fewer pigeonholes, you just add or subtract dividers. And if you need wider or narrower pigeonholes, you just change the spaces between dividers. You can also modify the way you mount the shelves, depending on the tools you have to work with and the money you have to throw around. I've made this demonstration cabinet to show you 3 possibilities. When you say sliding shelves to most modern craftsmen, the first thing they think of is metal extension slides. These move smoothly, and you can purchase the full extension version so the shelves slide all the way out of the cabinet. This allows you to easily find whatever is lurking in the back. But these slides are pretty expensive, and once they're mounted in the cabinet, you cannot easily change their position. Perhaps the easiest and the cheapest way to make sliding shelves is to cut dados in the dividers using a dado cutter or a router. Remember that the dado slots must be just a little wider than the plywood for the shelves to slide easily. Fortunately for us, plywood is usually just a little bit smaller than what it's bragging to be. Typically, 3/4-inch plywood is 1/32 of an inch thinner, and 19mm plywood is closer to 18. This is really annoying when you're building cabinets, but in this case, it works for you because a 23/32 piece of plywood slides rather nicely in a 3/4-inch dado. But I made the shelves in my pigeonhole cabinet to slide in 1/8-inch saw kerfs. To do this, I glued 1/8-inch thick plywood strips in matching kerfs in the edges of each shelf. Now, my original plan was to do this in aluminum, and then I discovered to my horror that this would have added $6 to the cost of each shelf. So I downgraded to plywood, and then I scraped the protruding parts of the strips so that they were just a little thinner than the kerfs in the dividers. This allowed the shelves to slide smoothly. This is a good deal more work than the dados, but the thin kerfs don't weaken the dividers as much as the wide dados. Consequently, you can cut them closer together, and this makes the shelves more adjustable. This brings us to the only part of this project that is remotely difficult. In order for these shelves to slide smoothly in their curves or their dados, all of those cuts must line up precisely in both the sides and the dividers. Fortunately, there is a simple trick to make this happen. Cut the sides and dividers, making the dividers the same size as the sides. This will make the dividers oversized, but we'll take care of that later. Cover the front edges of the sides and dividers with strips of solid wood to hide the plies, but leave 3 inches uncovered near the bottom edge for the kick plate. Set up your saw or router to make the first dado or kerf nearest the top edge. Make the first cut in all the sides and dividers using the same setup for all the parts. Remember to cut both sides of the dividers, but just the inside surfaces of the sides. Set up to make the second cut and cut all the parts again. The trick is that you're using the same setup for each dado and kerf in all the parts. So even if one setup is a little off, the resulting cut will be a little off in all the parts. The kerfs and dados will still match exactly and the shelves will slide smoothly. Once you cut all the dados and kerfs for the sliding shelves, trim the top, bottom, and back edges of the dividers to bring them to their final size. Then cut the rabbets and dados in the sides to hold the bottom, back, and top cleats. When you get to the shelf, remember to add finger holes to pull the shelf out and a backstop to keep stuff from tumbling off the back edge when you do. Also, if you use either the kerf or the dado method, wax the edges of the shelves. Apply a coat of paste wax and buff it. This helps the shelves to slide smoothly. The only other part of this project that needs a little explanation is the top. I wanted this to serve as a work surface, so I needed something durable and substantial. And over the years, I found that the best way to do this is to sandwich 2 sheet materials. The top is made from 2 pieces of particle board sandwiched between 2 pieces of hardboard. The particle board provides the strength and the bulk, while the hardboard is an amazing and underappreciated material. It's made by using high-pressure steam to literally explode the wood into its individual fibers, then mixing those fibers with a little water and compressing the slurry at 500 pounds per square inch until they rebond into a tough, hard sheet. One side of that sheet is then tempered by coating it with boiled linseed oil or tung oil and allowing it to cure. All of this makes the hardboard durable, water-resistant, and impervious to most workshop chemicals. To make the top of this pigeonhole cabinet, you need 1/2 sheet of 5/8 inch or 16 millimeters particle board and 1/2 sheet of 1/8 inch or 3 millimeters tempered hardboard. Oh, and some strips of hardwood if you want to make an attractive edge. When glued up, and this will take a bunch of glue, this will give you a work surface 1.5 inches or 38 millimeters thick. Be sure to glue up this sandwich so that the tempered surfaces of the hardboard, the smoothest surfaces, are facing out. That is, up and down. Why use hardboard on both the top and the bottom? Because it makes your work surface last twice as long. When the top surface becomes scarred by paint spills and temper tantrums, simply loosen the screws that hold it to the cabinet and turn it over. You'll have a whole new work surface, except for a couple of screw holes. So, how long does a top like this last? How often do I have to turn it over? Well, I've made many workbenches with sandwich tops just like this, and I can count the number of times that I've had to turn them over on 0 hands. I've always been able to wipe them off, even remove the stains with a light sanding and a little wax. So there's a definite possibility that the double surface top sounds like a better idea than it really is. But hey, if you need a new work surface, you already got one. Designing and building a pigeonhole cabinet that will work in your shop depends on 100 different factors, not the least of which are the tools and the hardware and the stuff you want to store. So I have no doubt that any plan that I could come up with will require at least some revision before this will work for you. Nonetheless, I put together a plan for this specific cabinet because, well, that's what I do. And I've included both imperial and metric measurements as always. If you'd like to see a set of plans for this pigeonhole cabinet, They're available from the Workshop Companion General Store. The link is either in the comment, the description, or both. Please like, subscribe, and buy something to keep these videos coming. And as always, thank you for your kind attention.